In this lesson, we're going to solve absolute value equations. The absolute value of a number, recall, is its distance from zero on the number line. For example, the absolute value of 4. It means you would ask yourself, what is the distance 4 is from 0 on the number line? So let's start at 0 to see what is its distance from 0. So 1, 2, 3, 4. So to get to 4, we had to jump 4, which means it is 4 units from 0 on the number line. Well, how about the absolute value of -4? To find the absolute value of -4, you ask yourself the same thing. What is the distance of -4 from 0 on the number line? Let's count. Starting at 0 again, but moving to the left to get to -4, we would have to jump 1, 2, 3, 4. So again, it is 4 units from 0 on the number line. So the bottom line is, one easy thing to remember is the absolute value of any number, whether it's a negative or positive, is always going to be a positive, because when we're talking about the distance, we are referring to a positive number in terms of how long or the distance of something. The only time an absolute value will equal a negative is if you negate it by putting a negative on the outside in front of the bar. Okay? An absolute value equation in the form of the absolute value of ax plus b equals c. If c, in other words, that number that's on the right side of the equation, if that number is greater than 0, then you will solve two separate equations. So you'll have both a positive and a negative value to the right of the equation. So you would have ax plus b equals c, or ax plus b equals -c. Now, if that number over to the right, c, is less than 0, meaning a negative number, then there's no solution, because recall, the absolute value of a number cannot be negative, only a positive value. And if the c, the value on the right side, is 0, then the absolute value of that equation will equal 0. Okay, let's do an example. Here we have x minus 2 equals 5. So since the number to the right side is greater than 0, that means we're going to have two separate equations to solve. So the first one is going to be x minus 2 equals 5, or the other one, x minus 2 equals -5. Notice we have removed the absolute value bars once we begin the process of solving the equations. So to solve both of them, we're going to have to obviously add 2 to each side. So on the first equation, if we were to add 2 to each side, that's going to leave me with x equals 7. And on the other, adding 2 to each side is going to leave me with x equals -3. So we have two solutions, 7 and -3. Let's check these solutions to see if indeed they are solutions. So if we remove the x from the original equation and replace it with 7, and then do it again and replace it with -3, let's take a look at what we would result in. So removing the x and replacing it with our solution values, we can see that in both cases it does check. So in the first example, 7 take away 2 is going to leave me with 5, and yes, the absolute value of 5 is 5. For the other one, combining a -3 and a -2 is going to give me a -5, and yes, the absolute value of -5 is 5. So our solution does check out. They are 7 and -3. In the next example here, we have the absolute value of x minus 4 equals 13. So the fact that the number on the right side of the equation, the 13, is a number greater than 0, that means we're going to have two separate equations. So that's x minus 4 equals 13, or x minus 4 equals -13. So to solve both for x, we're going to need to add 4 to each side. So when we add 4 to the first equation, that's going to leave us with x equals 17. Adding 4 to both sides of the equation on the second one is going to give us x equals -9. Now we're not going to continue to check each one of them, but those are your two solutions, 17 and -9. In this next example, again, we see here on the right side that our number 29, that is a number greater than 0. Therefore, we're going to have two separate equations. 2x minus 3 equals 29, or 2x minus 3 equals -29. To solve both of these equations for x, one of the first things we're going to have to do is to add 3 to each side. So let's go ahead and do that for the first equation there. We're going to add 3. Next, divide by 2, and x equals 16. For the second equation, let's go ahead and add 3 to each side. Divide by 2, and x equals -13. So my two solutions are 16 and -13. In this next example, it looks a little bit different because you have a number on the outer of the absolute value symbol, and the fact that it is joined together with the absolute value symbol with no sign in between it, meaning no plus, no minus, that means that it's being multiplied. So anytime it's sandwiched like that close, it means it's being multiplied. So to solve it, you're going to have to do the opposite operation, which is to divide by that number. Because to solve an absolute value equation, first of all, you need to make sure that the absolute value symbol is on the side by itself. So the first step to solving this is to remove that 7. And again, the way we get rid of it is doing the opposite. So let's go ahead and start by dividing by 7. Whatever you do to one side, you do to the other. And again, we're doing this to isolate the absolute value on the side by itself. So once we do our cancellations there, what we're going to be left with when we simplify it is the absolute value of x plus 3 equals 6. Now again, since this number 6 on the right side is greater than 0, that means that we're going to have two separate solutions, both a positive and a negative of it. So x plus 3 equals 6, or x plus 3 equals -6. To solve both of these equations, we're going to have to subtract 3 from each side. And when we do so for the first equation, it's going to leave us with x equals 3. And for the second equation, it's going to leave us with x equals -9. So our two solutions then are 3 and -9. All right, so here's another example. In this example, though, notice that you have a number that is sitting close to the absolute value bar with no sign in between it, meaning no plus, no minus. So what that means is that 4 is being multiplied with the absolute value. So one of the rules for absolute value equations, if you're going to solve them, is you have to isolate the absolute value symbol. In other words, get it by itself on one side. So we're going to have to do two things here in order to isolate that absolute value symbol. So we're going to have to subtract 5 from each side so that we can move 5 on the other side. We're also going to have to divide by 2, and remember, it's always opposite operation. The opposite of multiplication is division, and that's why we have to divide by 4. And over here, the reason we have to subtract, the opposite of addition is subtraction. So let's go ahead and subtract 5 from each side, and also we're going to divide the absolute value symbol by 4. So beginning with the subtraction, subtracting 5 from each side, then divide by 4. Once I do my cancellations, I now have the absolute value symbol by itself on the left side, and on the right side, 4 divided by 4 equals 1. So again, we now have it in absolute value form where we can solve the equation. The absolute value property states that if you have an absolute value is equal to some number that is greater than 0, then you're going to have two separate equations, both the negative and the positive. So what you're going to have is 2y minus 7 equals 1, and then 2y minus 7 equals negative 1. So for both of these equations, one of the first things we're going to have to do is to add 7 to each side. So beginning with the first one, let's go ahead and add 7. Next, we're going to divide by 2, and y equals 4. The other one, let's go ahead and add 7. That's going to give us 2y equals 6. Next, divide by 2, and y equals 3. So our two solutions then are 3 and 4. In this absolute value equation, we are given the absolute value of 5x minus 4 equal negative 6. And recall, with the absolute value equation property is that if the absolute value, the constant, in other words, if this number over here is less than 0, meaning that it's a negative, then there's no solution because the absolute value of a number is not negative. So therefore, there's no solution. So let me show you why this will not work. Okay, let's say we went ahead and solved it as usual. We would have the 5x minus 4 equals negative 6, and then 5x minus 4 equals 6. And then we proceed with adding 4 for both equations, and then divide by 5, and we get our two solutions. Let's go ahead and plug in these two solutions and see if these solutions work. So if we plug in both solutions and take a look at both scenarios, when we do the math, you're going to see in both cases that you wind up with a false statement. For the first one, once you do your cancellation of the 5s, you're going to have negative 2 combined with negative 4, which is negative 6, and the absolute value of negative 6 is not negative 6. the absolute value of negative 6 is 6. And on the other one, if you do 10 take away 4, you're going to get 6, and the absolute value of 6 is 6. It's not negative 6. So you can see in both cases that neither one is a solution because, again, the property states that if the absolute value of something of a number is equal to a negative, then there's no solution because the absolute value should always equal a positive number or 0. And so there you have it. In this example, we have the absolute value of 5 minus 3x equals 12. And our absolute value equals a number that's greater than 0. So we can go ahead and proceed by writing out our two equations, both the negative and the positive of that. To solve both, we need to subtract 5 from each side. And for both, we're also going to divide by negative 3. So starting with the first one, positive 7 divided by negative 3 is going to give me negative 7/3. And for the other one, once we divide by negative 3, you're going to have negative 17 divided by negative 3, and that's going to give us positive 17/3. And those are our two solutions. In this example, we have negative 3 times the absolute value of 4x minus 9 equals 24. So the first thing we need to do to isolate our absolute value symbol is to divide by negative 3. And you know the rules for equations. Whatever you do to one side, you certainly must do to the other. So let's go ahead and do that. Now we can cancel those negative 3's. So on the left side, we have our absolute value by itself. We have the absolute value of 4x minus 9 on the left side. And on the right side, we have 24 divided by negative 3. That's going to give us negative 8. And now we have the absolute value of 4x minus 9 equals negative 8. And recall, with the absolute value property of equations states that the absolute value of a number must always equal a positive. It cannot equal a negative. So therefore, there's no solution to this particular equation. In our last example of absolute value equations, here we have negative 2 times the absolute value of 7 minus 3y minus 6 equals negative 14. Pretty long one here. So you know step 1 is to work through the process of isolating the absolute value symbol, which means that we're going to have to add 6 to the other side so we can move 6 over to the right side. And then we're also going to have to divide by negative 2. So let's go ahead and begin first by adding 6 to each side. Next, we're going to go ahead and divide by negative 2. Remember, what you do to one side, you must do to the other. We can go ahead and cancel those negative 2's on the left side of the equation, and that's going to leave us with the absolute value of 7 minus 3y equals, and on the right side, negative 8 divided by negative 2 equals positive 4. Now, because we have a positive number over on the right side, we're good to go. So let's go ahead and proceed with solving our two separate equations. So we're going to have 7 minus 3y equals 4 and 7 minus 3y equals negative 4. Our next step for both of these is to subtract 7 from each side. Next, for both of them, we're also going to divide by negative 3. So for the first equation, negative 3 divided by negative 3, a negative and a negative, that's going to give you a positive 1. For the other one, once we divide by negative 3, we're going to have negative 11 divided by negative 3, which is positive 11/3. So our two solutions are 1 and 11/3. And there you have it, absolute value equations.